Okay, Advanced Algebra 2. This should be Tuesday the 28th. And welcome to Mr. Patterson's class if you are here watching also. This is Mr. Clendenin. And yesterday Mr. Patterson showed us how to do the law of cosines to find sides. Well, today we're going to flip that around and use the law of cosines to find angles. Okay. Now a couple things to note here. Why are we doing the law of cosines? Well, remember that with the law of sines, somewhere in your triangle, you have to know an angle and a side opposite of it. You have to know both of those if you want to do law of sines. So law of cosines comes into play when you don't know an angle and a side opposite of it. Okay? So you had those three options for using the law of cosines, depending upon which angle you're looking at. And we'll talk today just specifically about how the pattern of the formula plays out, so you don't have to try to remember all three. Okay? All right, first thing, here's what we have to find. We have to find the largest angle. So we got to remember a little geometry. Where is the largest angle at in a triangle? If we look at our triangle over here, we don't have any angles at all. Where is the largest angle going to be? Well, it's going to be opposite of the largest side. Okay, so which one is our largest side? 13 is our largest side. Well, guess what that tells us about angle B? That it will be the largest. So this question, find the largest angle, we have to look at our triangle and figure out which one they want us to do first, or we'll be doing the wrong thing. Well, the largest angle is opposite the largest side. Okay. Now you notice in this triangle, we don't know angle A. We know side A, but we don't know angle A. We know side C, but we don't know angle C. And we know side B over here, but we don't know side B. So that means we cannot do law of sines. We have to do law of cosines. Let me just get rid of all my drawings here before it gets too crowded. Okay, so here's how this works in the law of cosines. You want to find angle B because it's the biggest, because it's got the biggest side. So you take that side and you put it over here all by itself. Then you take your other two sides, which in our case are the 9 and the 8, and you put them on the right-hand side of the equation. So 13 squared equals 9 squared plus 8 squared. So it starts out looking a lot like Pythagorean theorem, but we don't have a right angle up there, so it can't be Pythagorean theorem. Well, it's got this extra little bit added on to it. It's always minus 2 times the two sides on that right-hand side of the equation, 9 and 8, and then times the cosine of angle B. So a couple things to notice here about this. This is the only place you'll use 13. You don't use 13 over here anywhere. All right? Whatever angle's opposite your 13 has to be over there on the right-hand side, cosine of angle B, and B is opposite over 13. So just keep that in mind. This 13 that's over here, that's the only place you'll put 13. You fill in the other side with your other two sides, the 9 and the 8. All right? Now, we got to be careful now when we start to punch this in our calculator, because there's a lot of places you can make easy mistakes. My recommendation is to do it in pieces. Okay? So we can do 13 squared, we get 169. 9 squared is 81, 8 squared is 64. Minus, then we can do 2 times 9 times 8, we get 144 times the cosine of B. And what you need to notice on this right-hand side is the 81 is all by itself, the 64 is all by itself, but the 144 is not. It's being multiplied by the cosine of B. Okay? So this 144 is different from this 81 and this 64. Since the 81 and the 64 do not have a cosine of B attached to them, we can add those two together. And what do we get? We get 145. Now it's going to be tempting right here. And listen close. It's going to be tempting right here to subtract 145 minus 144 and get 1. But you can't do that. Cannot do that. Don't ever subtract those two. Okay? Why not? Because that's not 144 back there. It's 144 times the cosine of B. Okay. Take a little drink of my Mountain Dew. But what we can do is take this 145 and subtract it over, just like we were solving normal equation. Okay, and let me come over here so I got some more room. When I subtract that, I get 24 equals negative 144 times the cosine of b. Now, if you're multiplying by negative 144, we can get rid of it by dividing. And what do we have? We have 24, I'm going to put my negative up on top, over 144 equals the cosine of b. Now, you don't have to reduce 24 over 144 if you don't want to. Calculator will do it for you. But we are trying to get b by itself, so we got to remember some past material here. How do I get rid of this cosine right here? I do an inverse cosine. That will make them cancel out. I just got to do it on both sides. So what do we end up with? We end up with the inverse cosine of our negative 24 over 144 will equal these inverse cosine and cosine will cancel out, angle B. All right. If you can see that, it might be behind the Doseri label here. Let me rewrite it right here. It says the inverse cosine of negative 24 over 144 equals B. And I haven't touched my calculator yet unless you had to do grab your calculator to do some of that multiplication and squaring up there. But now I didn't make anything a decimal, I guess is what I'm trying to say. Now I'm going to punch this all in my calculator at one time using the fraction button. Make sure you hit second cosine. Okay, on my calculators. Whatever you have to do on your calculator, you get an inverse cosine. And when I do that, I get angle B to be. Now remember, angle B was supposed to be the largest one, 98 degrees. So that's pretty big, that's obtuse. And if you remember in your geometry, you can only have one obtuse angle per triangle, so it will be the biggest. Okay, so a big part of this is, after we get it set up correctly right here, is walking through it correctly with our calculator. Okay, so we're going to do another one here, and that's kind of the big thing today, is making sure we can get our calculator to do this the way we want it to. Okay, so let's take a look at another one. Okay, same directions, find the largest angle, so we know that has to be opposite of the largest side. Well, that means that would be angle A. So we are going to be finding angle A in this problem. So what do? We take that 22 that's opposite angle A and we put it over there by itself. Then we use the other two sides, the 15 and the 9. It doesn't matter how you put them in. 9 squared times 15 squared, or 15 squared times 9 squared, minus 2 times that 15 and that 9 times the cosine of angle A. Now you might want to pause right here and see if you can't work your way through this with your calculator before I do, and then we'll compare at the end. So I'll give you a second here to pause. Okay, so I do it in pieces. 22 squared is 484. 15 squared, 225. 9 squared is 81. 2 times 15 times 9, 270. And then we have times the cosine of angle A. Now remember that 270 is being multiplied by the cosine of angle A. These two are not. 225 and 181, however you have them in there. So we can add, go ahead and add those two together and get 306. Make our equation a little smaller. Remember what I said, let this stick in your head. Never subtract those two. It's tempting, but you cannot, because that 270 is being multiplied by the cosine of A. If you have 6 minus 6x, you cannot subtract those. If you had 6x minus 6x, you could, because they both have the x's. This would be like both of them having the cosine of A on them. We don't have that. So we cannot subtract the 306 and the 270, but we can subtract the 306 from the 484. And we will get 178 equals negative 270 times the cosine of A. Divide that over, get your fraction, and I would move my negative up top. And now you're ready to finally figure out what angle A is and how to, so we got to get rid of this cosine. So we multiply by the inverse cosine to make them cancel, and then we'll just get angle A over there. But we would also have to multiply by the inverse cosine on the left hand side. Well, that tells us exactly what to punch in our calculator. And we don't have to do any rounding anywhere up to this point. So we just type that in our calculator. I think our fraction button would handle that. And I got, remember, angle A here is supposed to be the largest angle. I get 131 degrees. So hopefully you got that. If you didn't, let us know. You may have to send a picture of a calculator to us so we know what kind of calculator you're working with. But it does point out another thing I want to bring up. Notice that angle A does, go up here and look at my picture. Angle A does not look like it's anywhere close to being 131. So what you got to realize is when we draw our triangles, they're not going to be drawn to scale, okay? We got to go by what the numbers give us whenever we do the work, all right? Okay, so that's it for the examples. Your homework, there they are. You can pause and copy those down. And again, I got a little note up there that the triangles may not be drawn to scale. Okay, in both of these, you have to find the largest angle like we did in our examples. That's the only answer you have to find. Okay, so good luck. Let us know of any questions in Hangouts and email, and however you're getting hold of Mr. Patterson. Hangouts has worked well for me. And I think that's all I have for you. Have a good day, rest of your day, and we'll see you tomorrow.